All right. So now that we've done the discussion on tokens, we now want to see how to find their token IDs. How do we convert those tokens into numbers? So I will just write token IDs here. Okay, token IDs. So because these tokens that we have, they are still strings. We need to convert them into integers because that's what um that's close to what neural networks want. They want numbers that they can work with. Yeah, it's just an intermediate step. It's not really the end step, but okay, let's see how this happens. We're going to build a vocabulary. Like I mentioned, we'll build a vocabulary, and this vocabulary will have a way of mapping each token with the string itself to a token ID. So for example, let's just take our training set. Let's say this is our training set with all the text in it. So this will be the complete training set, complete training set with all the words and um all the documents in them. If that's the case, what we will do is we'll use this as an input, the input text, and we will tokenize it. We will tokenize it just like we did in the previous chapter, where it breaks down the input text into individual tokens. So you have your individual tokens like the uh, quick, the quick brown, the quick brown fox, blah 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 blah, going like that. And this is now the tokenized data set. That's our tokenized data set. We just converted them. In previously, we just used simple regex where we just split by the space and then cleaned up stuff, cleaned up what was left over, and we have our individual names like that. What you then do is you calculate unique tokens. So at this stage here, you calculate you extract unique tokens, unique tokens. And in Python, you can use the set. The set function allows you to get unique tokens because you might have 10,000 pairs in your data set or whatever it's going to be. But here you're now just calculating unique tokens. Oh no, I think I changed my pen size. Let me just lower the pen size. Let's see if we still write properly. Yeah, I think this is fine. So you now have your unique tokens. When you have your unique tokens, you then sort the unique tokens alphabetically. You sort alphabetically. Usually, that's what happens in a dictionary. They're usually sorted alphabetically. After you've sorted them alphabetically, then you just add a count to them or a number to each one of them. So when you sort that statement, the quick brown fox, imagine that was our complete data set. The quick brown fox jumps over the lazy dog. If that was our full data set, training data set here, we will have brown as the first token, right? And this is now given ID 0. And then the next token will be dog, and this is given ID 1. And next one is fox, which is given ID 2. I think it's like jumps. Jumps is now ID 3. Uh, lazy. Lazy is ID 4. So scroll down a bit. Um, and then over, that's ID 5. And then quick, that's ID 6. And finally, the is ID 7. And yeah, I wrote with a small letter just for illustration purposes. But in real life, this type of there is usually treated differently to a capital letter there. Just to be for completeness and for the model to actually know sentence structure and all of that. So now that we have now this becomes our vocabulary. These are the unique tokens. These are the unique tokens, and these are the unique IDs. These are not unique. They're just token IDs. They become the token IDs. No need to say unique because we're already building on top of something unique, and we are just incrementing by one for each one. So this is now our vocabulary. That's our vocabulary, which contains all unique tokens in the training dataset. Um, Now that we have this mapping. Let's take a look at the code where we actually showed this. So get back to Chrome. So in this, that's what we're trying to do here. What we're trying to do is when we get our book that we've pre-processed, because you remember in the previous video we pre-processed that book, split it into tokens. Now we are just going to use the set to get the unique tokens and then sort them. And the vocabulary using that book becomes 1130 tokens. That's what we have there. And so here we create a dictionary just to do the mappings. So token and integer. For integer and token, you can read the lines of the Python code. They're quite self-explanatory. So yeah, as I said, we're not going to get into each line, but here we're now creating our vocabulary. And just to see the first 50 entries of our vocabulary, the exclamation mark has been given an ID of 0, double quotation marks, ID of 1, and all of that. And we see A is 11, R is 12, among 13, and 14, and all of that. So these are the first 50 in our vocabulary. Now, here, we are going to what we're going to do now is we 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 actually want a way. Well, before we get to the class, let's see how we apply this type of thinking. So let's get back to our whiteboard here. So we've created our dictionary. So imagine now we have simple text like simple text. If our simple text is the brown, because we created our dictionary, right? Brown dog playfully chased, playfully chased the swift fox. That is our simple text. We're going to tokenize the text. First, tokenize it. With our simple tokenizer, we just break it into individual words. But like I mentioned, I've been mentioning previously, um, tokenization could break the word into subwords. But for now, we're just doing the simple tokenization. So this is what we have with our tokens. And then we add the we add the we then connect this to our vocabulary. So our vocabulary says brown is 0, dog is 1, and just the last one, fox is equal to 2, is the ID 2, going like that. So this is our vocabulary. So what will happen then, we then start tokenizing it. We'll be like, there is ID 7, and then brown is ID 0, and dog is ID 1, all of that. So now in our new simple text, we would have tokenized it into token IDs using our set vocabulary. So this is a set vocabulary that we had on the side. I'm going, some people might have already picked it up, but I'm going to discuss it soon. Um, so now that we have done this, In the previous video, we showed that after the large language model has processed everything, there's a need for you to convert it to convert the answer, because in large language models, there are neural networks which are return numbers. There's a need for us to change those numbers back into into text, and that is where what we would call an inverse vocabulary comes in. And it's just the way, it's just exactly what the name says. It's just the inverse of our vocabulary. And this is now done by something called, we can call the decoder. The decoder takes it back into into natural language, takes the numbers back into natural language. Here, what we're doing actually in this process where we are changing simple text into numbers, we are using an encoder. We are encoding the simple text into numbers. And after the neural network is processed and all of that and returns some numbers, we then use the decoder to decode those numbers back into natural language. Here we just create an inverse version of the vocabulary that maps the token IDs back to the corresponding text. So our token IDs will be 0. This will now be brown. And then token ID 1 will be dog. And that's it. So if it returns a 1, if it's a class, let's just say as a simple example, it's a classifier, and then it says, oh, I'm going to classify this. The next word that I want to predict is token ID number 1. We know that the next word is the dog. So that's just it. It's just an inverse of the map that we already have. So let's see this in code. In code, how we are going to do that. Let me just switch screens here. So we are creating this simple tokenizer class, which is the encoder class. Encoder class just does everything that we have done and returns the IDs. And the decoder class just takes all of those IDs and then just returns the strings. Returns the string by doing the lookups. That is what we are planning to do here. That is what we're planning to do in this simple tokenizer. And it's a simple tokenizer, like I mentioned, just because it's splitting the way it's splitting here. That's why it's simple. We are not doing subwords or anything. We're just simply splitting words. So the encode function turns text into token IDs. The decode function turns token IDs back into strings. So that's essentially what it's going to be, and it's using these. As you can see here, this is now the reverse vocabulary, and this is our original vocabulary. Simple like that. So now, if we have a text like this, let's apply the tokenizer. If we have a text like this, it's the last paint. It's the last he painted. Miss Gisborne said with pardonable pride. It's there it's there in the verdict. Let's see how the encoder encodes this. It encodes this into these token IDs. Now, if we want to decode those tokens back into integers, we would do it this way. You use the decoder. We just send these token IDs into the tokenizer, but into the decode function, and it picks out what the actual words are in the inverse vocabulary. And that's it. So if you put it in one line, you encode the text and then you decode the text, you get this text back. Um, so yeah, it has successfully converted the token IDs back to original text. But there is a problem. There is a problem. Let's go back to show why there is a problem. What if, so now that we have our vocabulary that we created from our training data set that we had here, our training data set that we had in this example was just that the verdict. The verdict was created our vocabulary. So now imagine we have a text like this. Hello, hello, hello world. Do you like tea? Let's say we have this text. What we are going to do, if we apply that encoder It's going to split these into tokens, right? It's going to split these into tokens, all of these into tokens. But the problem is we are going to get an error because of this word here, this token here, hello. The token hello is going to give us an error. It's Python will show you a key error. The reason why it will show a key error is because in our vocabulary, we did not have the word hello like this. So it will say, I cannot map this into any token ID because it is not existent in my vocabulary. So it will give a key error. So that is the topic of the next video, where we talk about how do we add special tokens. Let's see what the special tokens are going to be.